Hi, I'm Cheryl Leach. In this problem, we're going to be finding the absolute extrema of my function on an interval. The first thing I want you to notice about this problem is my interval. It's the interval from 0 to infinity. The extreme value theorem tells us that you will always be able to find an absolute minimum and maximum if you're looking at a closed interval. But we don't have a closed interval this time, so we'll have to see what happens. Well, I know that my absolute extrema can occur at critical numbers and also at endpoints. I'm a little worried about the endpoints, but let's go ahead and talk about those critical numbers. We're going to find the derivative. And in this case, I'm going to need to use the quotient rule. So I'll take the bottom times the derivative of the top, which is 0, minus the top times the derivative of the bottom, which is just a 1, all over that bottom expression squared, which all reduces to minus 8 all over the quantity x plus 1 squared. To find critical numbers, we need to know when that derivative is equal to 0 and when it's undefined. So when does it equal 0? Well, a fraction equals 0 when the numerator is 0, and negative 8 can never equal 0. So there won't be any critical numbers that we get from that condition. But we also need to check when is the derivative undefined. This happens when the denominator is equal to 0. So what happens when x plus 1 quantity squared equals 0? Well, that leads to x plus 1 being equal to 0, which means that x equals negative 1. So negative 1 is a critical number. However, I want to find the absolute extrema on the interval from 0 to infinity. While this is a critical number, it's not located on that interval, so I don't need to consider it. So since I don't have any critical numbers to deal with, the last thing to look at would be the endpoints. So let's check out the endpoints. We'll start with f of 0. This I can calculate. F of 0 will be 8 over 0 plus 1, or in other words, 8. But here's where the problem comes in that I mentioned at the beginning of this video. I don't have a right endpoint to use. So now, even though I know that the point 0, 8 is on my graph, I don't know whether that's the smallest value or the largest value. Well, let's take a little closer look at this derivative. My derivative is minus 8 divided by x plus 1 quantity squared. I know this number, whatever value of x I plug in, will be a negative number because when I square x plus 1, I'm guaranteed to have a positive number in the denominator, a negative number in the numerator, which will lead to a negative derivative. That tells me that my function is decreasing. So if you have a function that's decreasing, the left endpoint is the one that's going to give you the absolute maximum. So 8 is the absolute maximum. Now, what about an absolute minimum? Okay. Well, because my interval goes to infinity, this graph keeps getting lower and lower and lower, and there's no lowest point on my graph. I hope this was helpful. Thanks.